So thank you very much. We talked a lot about, in these introductory greetings, we talked about the Pond Initiative. So let me change gears a little bit, because we also have an intellectual theme. We are, after all, the Pond is about philosophy of science around the Mediterranean. So we spoke about the Mediterranean, and now we shift gears to the philosophy of science. We chose as our theme for this inaugural meeting the relevance of philosophy of science to science, and this is the topic of the talks we're going to hear this morning and tomorrow. Each talk will be given by a representative of a different country around the Mediterranean, with the exception of Greece, that offers us 2 participants that you'll meet, those of you who haven't yet. And our speaker, the first speaker, is Professor Berna Killinc from the Department of Philosophy at Bogazici University at Istanbul. In the past, Professor Killinc worked on history and philosophy of science, for example, on whether chance should be allowed to play a role in scientific explanations, particularly in Kant's view. But in the more recent research of Professor Killinc, she's interested in formal epistemology, in particular, the updating of beliefs. For example, she wrote on how to form a decision given inputs from various kinds of experts who may make clashing recommendations. So, and the title of today's talk is Third Philosophy. Please.
Okay, yeah. Well, thank you for inviting me, and especially with such a, rough title. Hopefully, at the end of the talk, I'll try to make some connections to my title. But you will see soon what I will talk about. Okay. Now, sometimes philosophies of science do have some relevance to sciences, as, for instance, a leading scientist of the 20th century made note of. He said the type of critical reasoning which was required for the discovery of the central point was decisively furthered, in my case, especially by the reading of David Hume's and Ernst Mach's philosophical writings. I guess you can guess who the author is. That was Einstein. While for the most part, philosophy of science does not have an existential import on sciences, very rarely at least, it does have some such impact. And I have in mind the kind of work carried out by psychologists and behavioral economists, such as Daniel Kahneman and Amos Tversky, scientists which would be very familiar to the Israeli audience, I guess, in their search to understand human rationality. So, Kahneman and Tversky carried out empirical studies on how naive or sometimes educated people reason by asking them questions, usually word problems, and asking them to make inferences on the basis of the information provided in those problems. You may be familiar with some of the questions that circulate in this literature, for instance, the Linda problem. There's a host of such test questions, so certainly I won't go over them in any detail, but I want to pay attention to one specific problem that they investigated, namely the problem that's referred in the literature as the engineer versus lawyer problem. You may be familiar with that too, but let's look at the description, the longer version here. Let me give you a minute to read it, maybe. At first, at first reading, the problem may not be very transparent. So here's a simplified version I have penned down. There are 30 engineers and 70 lawyers in a group, and they've been interviewed, and a brief profile of each has been written. You will be given a description of a profile chosen at random from the 100 available descriptions. For each description, please indicate your probability that the person described is an engineer. And here is one of the descriptions. The subjects were presented. Jack is a 45-year-old man. He's married and has 4 children. He's generally conservative, careful, and ambitious. He shows no interest in political and social issues and spends most of his free time on his many hobbies, which include home carpentry, sailing, and mathematical puzzles. The probability that Jack is one of the 30 engineers in the sample is, a sample of 100 is blank, to be filled in by the subjects, percentage. So this is a typical question that they tested, and as you can imagine, most subjects thought the profile was that of an engineer. But to see if the information about the number of engineers in the sample group mattered or not, they changed the question, reversing the number of engineers and lawyers. Instead of 30 engineers, now they asked a version of the question with 70 engineers. And the response rate did not change. So apparently, they came up with that conclusion. The base rates, that is the ratio of the engineers to lawyers in the initial population, did not make any impact on the way people inferred their conclusions. And the conclusion or the explanation Kahneman and Tversky came up with was that instead of probability theory, people rely on certain decision-making heuristics, which may be useful at times, but which may be terribly misleading in some other contexts. In this example of the engineer versus lawyer problem, they identified the heuristics as the representativeness heuristic, according to which you choose the items in a given list, let's say, that appear most representative of the category given as evidence. So the profile seems to be more typical of an engineer and more representative of an engineer, so you choose that as your answer as opposed to the prior probabilities. In the literature, this goes as the base rate fallacy or the base rate neglect. The base rate being the composition of the original population. And how could Kahneman and Tversky and several other researchers like them be so confident that that was a fallacy, indeed? They relied on, of course, the norms that were provided by probability theory and the way probability theory or Bayesian updating rules were developed by philosophers of science. So they would say that the design of this experiment permits the calculation of the normatively appropriate pattern of judgments. The derivation relies on Bayes' formula. The emphasis here is that there are norms of reasoning, and we're testing people against those norms to see if, they reason correctly or not. And a modern version of this rule, Bayesian updating as it's called, this is from the Stanford Encyclopedia. I guess most of you are familiar with it, but let me just go over it. If one begins with prior probabilities, PI, and one acquires new evidence which can be represented as becoming certain of an evidentiary statement E, then rationality requires that one systematically transform one's initial probabilities to generate posterior probabilities, P sub f, by conditionalizing on E. That is, where S is any statement, the final probability of S, Pf of S, is given by the conditional probability according to the initial probability assignment of S given E, provided that E is the total evidence that one has acquired in the updating process from E to F, and that the initial probability of E is different from 0. That is the standard rule as stated in the Stanford Encyclopedia. There are toy examples of that. I don't know if you've seen them. You can teach children how to reason the Bayesian way using Lego bricks. I won't go over it. I am just, showing it for fun. You can compute the initial probability that a given brick, let's say a dotted brick, is a yellow brick is in the whole sample space, and compare it with the probability of the yellow brick being on the sample space, given that it's on the blue brick space. Now, these results of Kahneman and Tversky created a big uproar in both the empirical literature, scientific literature, and the philosophical literature. Aren't we a bit rational, or rational after all? Aren't we, super intelligent animals that we thought we are? So from many quarters, both from philosophical and scientific quarters, the validity of these findings came to be questioned. In this talk, I will focus specifically on one movement or one strand of questioning Kahneman and Tversky's approach, namely that provided by Gert Gigerenzer and his team in Max Planck Institute for Developmental Psychology, partly because I once worked as a lab assistant in their team, so I have some idea about maybe a better insight about the way they're trying to tackle this problem of rationality. Gigerenzer's project is not simply questioning in a piecemeal manner, each and every rationality test, but also questioning the approach holistically. They think there's something fundamentally wrong in Kahneman and Tversky's approach because they rely on the norms provided by a priori theories and evaluate rationality vis-a-vis those norms. As Gigerenzer puts it, before simple heuristics, which refers to their first book, Simple Heuristics That Make Us Smart, a largely unquestioned view was that humans and other animals rely on heuristics, but that they would do better if they would process information in a rational way, identified variously with propositional logic, Bayesian probability updating, or the maximization of expected utility. In contrast, we argued in simple heuristics that there is no single rational tool for all human tasks based on some logical principle, but an adaptive toolbox with specific tools implementing bounded rationality, each tool based on mental core capacities. As a consequence, the proper questions are which tools work well in a given environment and why. These are the questions of ecological rationality that we explore in this book. The vision of rationality is not logical, but ecological. I would like you to pay attention to this contrast between logical and ecological, as I will return to it later, evaluating their position. Further on ecological rationality, they say that the study of ecological rationality is about finding out which pairs of mental and environmental structures go together. It's based on environmental description, computer simulation, empirical test, and analysis and proof, and it centers on three questions. Given a heuristic, in what environments does it succeed? Given an environment, what heuristics succeed? And how do heuristics and environments co-evolve to shape each other? So all in all, their goal is to generate heuristics that will work in specific contexts or in specific ways those contexts are perceived by the subjects that are being tested. As a result of this approach, we can already see that the original input of philosophy of science is being discarded as it's no longer scientific rationality of the Bayesian type that Gigerenzer and his team is trying to see in naive subjects to test their rationality, but they're trying to develop alternative norms of rationality. They wouldn't call it probably norms, but still they function as local norms of rationality. So returning to that specific problem I had mentioned earlier, namely base rate neglect, I was wondering how their approach would tackle that problem. Would they concede that naive, uneducated subjects still perform very badly on such Bayesian updating problems, or do they have a way of accounting for it in different ways? Now, the solution they put forward to the base rate neglect, for instance, in this paper from 1998, is that the reason why naive subjects perform so badly on the Bayesian type of updating questions is that they don't understand probabilistic talk. In particular, they don't understand single event probability ascriptions. As they say, information from the environment is stored in terms of natural frequencies rather than percentages or ratios. People do take into account base rates when the wording of the problem is changed. And here is the example to how they change the wording of the problem. The original problem, for instance, this is a slightly different problem that they made use of regarding the prevalence of a disease in a population, and then a test result that may indicate the presence or the absence of that disease. In the probability format, the question is, if a test to detect a disease whose prevalence is 1/1,000 has a false positive rate of 5%, what is the chance that a person found to have a positive result actually has the disease, assuming that you know nothing about the person's symptoms or signs? So this is the probability format of the question, similar to the version that Kahneman and Tversky and others in the literature have employed. And this is their version in what they call the frequency format. 1 out of every 1,000 Americans has disease X. A test has been developed to detect when a person has disease X. Every time the test is given to a person who has the disease, the test comes out positive. That is, the true positive rate is 100%. But sometimes the test also comes out positive when it's given to a person who's completely healthy. Specifically, out of every 1,000 people who are perfectly healthy, 50 of them test positive for the disease. That is, the false positive rate is 5%. Participants are then told that a sample of 1,000 Americans were selected by lottery and given the test. They then had to answer the question, how many people who test positive for the disease will actually have the disease? And the blanks to be filled out are not percentage probabilities, but natural frequencies, 10 out of 51 or whatever. On this version of the question, their finding is that 56% of the subjects gave the correct 2% response, as compared with only 12% on the original version. So to reiterate their conclusion, I think there's a typo here. Logical rationality is not determined a priori. That is, what is good and bad is not to be decided by abstract principles. Instead, they should be tested by testing behavior in natural environments. Sorry, I think there is some mistake with this quotation. What I find interesting in their handling of the base rate neglect problem is that they don't really propose a radically different norm to understand subjects' behavior. They basically abide by Bayesian reasoning formulated in terms of frequencies. So they don't change the normative theory at all. This is in sharp contrast to some other test problems that they have investigated and proposed alternative norms that people may justifiably be using of. So what this suggests, given their formulation of ecological rationality, is that perhaps some principles of rationality are local. They're only good for specific contexts under specific constraints on reasoning. For instance, when you need to give a fast decision. But their approach does not conflict with the idea that there may be some more global principles of reasoning that are good in many different contexts. And perhaps there are some universal principles of reasoning of the sort that the Bayesians came up with. So it's not that they can entirely replace, with this approach, the former emphasis on certain a priori principles of reasoning. Concerning these developments, I find some new developments that are really striking and coming again from philosophical quarters that cognitive psychologists should take account of. And what I have in mind is works such as Joseph Halpern's Reasoning About Uncertainty from 2005. What's notable about these approaches that's exemplified in Halpern's work is that they allow for a plurality of norms, unlike the earlier approaches in Bayesian epistemology. So Halpern states that probability, that is the classical point-valued axioms of probability, is not the only way of representing uncertainty. There are a number of alternatives, each with their advantages and disadvantages. And in his repertoire, we can find the treatment of qualitative probabilities, that is, ordinal or ranked ranking probabilities, interval value probabilities, which is, again, a very recent development, possibility theory, ranking theory, and their own plausibility theory. These are some of the major alternatives to the standard traditional account of probability. And what's nice about Halpern's treatment is that he can define a notion of updating for each different theory that he's proposing. So it is possible to emulate Bayesian updating principle in these different frameworks, but possibly with different results. And it's noteworthy how Halpern describes the motivation for his undertaking. He says that one reason for wanting to consider representations of uncertainty other than probability is the observation that, although it's well known that people are not very good at dealing with probability, so they are not in agreement with Gigerenzer and his team, for the most part, we manage reasonably well. We typically do not bump into walls. We typically do not get run over crossing the street. And our decisions, while certainly not always optimal, are also typically good enough to get by. Perhaps probability is simply not needed in many mundane situations. And another interesting feature of the approach of Halpern and the tradition that he is representing is that they don't simply develop a priori theories without paying attention to how updating is to be implemented by human or artificial system subjects. They do pay attention to memory constraints, to computational constraints. So here is a long quote you can just skip over, but perhaps, you know, the last two sentences, they do describe, you know, the difficulties in implementing some of their findings when real memory constraints are taken into account. And they ask, how should updating work in this case? And they say that depends on the details of memory management, and they do pay attention to that. 5 minutes. Another favorite work of mine in a similar vein is that by Keith Stenning and I think there's a typo there, Michael van Lambelgen, in their work Human Reasoning and Cognitive Science from 2012. Their project is described as seeing logic as the mathematics of information systems, of which people are one kind, is quite a good first approximation to the view we develop here. This view helps in that it makes clear from the start that one's choice is never between doing psychology and doing logic. Understanding reasoning is always going to require doing both. And how do they do both? They say, we now apply the availability of a multiplicity of logics back onto the subject matter of discourse and psychology. So they do pay attention to how people understand written texts to start with, discursive information, and also the mental representations of real-life environments. And they emphasize that logic is very much domain-dependent in the sense that the valid schemata depend on the domain in which one reasons and with what purpose. So I'm very fond of these developments, and I believe it shows us something about doing philosophy in this new era of collaborations between psychologists, empirical scientists, and logicians. So coming to my makeshift title. I wonder if you have any guesses about what I wanted to refer to. Third philosophy. Of course, I gave the title to Orly at a moment of utter despair during the recent coup attempt in Turkey, realizing that, you know, we're a third world country again, where military can intervene so freely. But I want to make a more interesting connection to wrap up my talk. And the connection goes through Descartes' idea of first philosophy. You may all know this passage from Descartes. In the Principles of Philosophy, he says, "The whole of philosophy is like a tree. The roots are metaphysics, the trunk is physics, and the branches emerging from the trunk are all the other sciences, which may be reduced to three principal ones, namely medicine, mechanics, and morals." I like this organic sort of interconnectedness of disciplines embedded in this logic metaphor, in the tree metaphor. But of course, the metaphor also indicates some sort of hierarchy. Well, this is second philosophy, even though Descartes wouldn't call it probably second philosophy, but the second part of philosophy is physics. That is the most general empirical science of material objects. And Descartes would say that first philosophy cannot be violated by second philosophy or by third philosophy. First philosophy is primary in the sense that it embodies necessary a priori truths one should abide by doing second or third kinds of philosophy. So he says, this is a very interesting passage in the Principles, the hypothesis that the universe was originally chaotic and entirely without form is morally certain. Morally certain because this hypothesis can explain all the observations we've made in the world. We can show how species could arise from that universe and so on. However, we know with the greatest certainty possible that this hypothesis is false, because God has revealed in Scripture that fixed species and so on were present at the creation. So however certain one can get doing second philosophy, the certainties provided by first philosophy would trump those. Second philosophy is subjugated to first philosophy. And this is, you know, diametrically opposed to the role of philosophy of science in discussions of rationality that I believe is suitable. So there is a philosopher who did try to develop second philosophy in explicit contrast to Descartes' first philosophy, and that's Penelope Maddy in the wonderful book called Second Philosophy, A Naturalistic Method, where she tries to develop her version of naturalistic approaches in philosophy, and she puts it more as a project to understand how a priori positions can be challenged or can be given naturalized grounds. Now, my conclusion, certainly I don't espouse first philosophy a la Descartes. I don't think a priori metaphysical principles and even a priori logical principles don't have an important role to play in understanding human rationality. In different fields, it may be different. I'm not entirely sure, however much I'm fond of Maddie's approach, I'm not entirely sure she can succeed in her project and get rid of the normative criteria entirely. So I was thinking, could there be a third way, a third philosophy? Of course, I don't have any time to talk about what sort of a philosophy it would be, but it seems to be already exemplified in the teamworks we find in current research in cognitive psychology. So, for instance, Gigerenzer says, we set out on this journey as a group of individuals trained in a number of disciplines, including psychology, economics, mathematics, computer science, biology, business, philosophy, the law, medicine, and engineering. So it's a big collaboration. Of course, this description is faithful to disciplinary division of labor, but it could also be a tribute to traditional ideas of disciplines. I wonder if people, researchers should be so much distinguished insofar as which disciplines they were trained in, but perhaps, we should say that they are all scientists of rationality, philosophers included, with different specializations in this field. So to conclude, just 1 second, I want to use this boat metaphor. You may be all familiar with it too, but given that this is a conference around the Mediterranean, I thought both metaphors may be of interest. Quine says, in Word and Object, that Neurath has likened science to a boat which, if we are to rebuild it, we must rebuild plank by plank while staying afloat in it. The philosopher and the scientist are in the same boat. Of course, we know that boats have been sinking numerously, but I don't want to end in that pessimistic tone. I hope that we do manage to develop accurate accounts of rationality and also improve the way people reason so as to create a better world. Thank you.
Thank you very much. And there is some time for comments or questions. Please. Please, Lilia.
I have a simple question. All this research in cognitive science.
There's a microphone?
The question is following. All this research in cognitive science is done on studying rationality of everyday reasoning. But could you transfer all these findings to scientific reasonings? Because actually the science originally appeared in order to improve all the deficiencies of everyday reasoning. So we cannot transfer all these findings and the conclusions from these findings to scientific reasoning. What do you think about that?
I believe so, and especially I mentioned Gigerenzer and team's efforts to divorce studies of human rationality from studies of scientific rationality, right? So they don't necessarily want to employ Bayesian updating principles in their framework, but they do end up using them nonetheless. But on other, questions, they do challenge norms developed by philosophers of science, and those norms were developed to account for scientific rationality. So I think that there is a divorce, and philosophers of science need not learn from human rationality so much, or everyday rationality so much.
Please.
Thank you. It was very interesting. I just want to make two short comments. One is, and see what your reaction would be. One is that it doesn't seem to me, I mean, it seems to me that we should look at the ball, and the main issue about scientific reasoning is that it is essentially based on induction, and induction is invalid logically. So, if you take, so I think this has to be brought into the context here, and as far as Bayesian updating or Bayesian reasoning and so on doesn't amount to giving a solution to the problem of induction. So, I mean, I just want to put it into context and say that there is a big bad bug in all of this scientific reasoning insofar as logic is concerned, and so that's one point.
There's a big what?
A big bad bug.
Okay.
Okay. The other thing, the other comment, so I just wanted to bring it into the discussion. The other comment, a short one, is that with respect to the discussion you had from Descartes and the surrounding issues that came up there, I just want to say that about a priori truth or something like that. I think that one can easily see in the development of modern reasoning, in physics, for example, say in the 20th century. But I think that you can go back also and say similar things with respect to older theories in physics, even about Newtonian mechanics. But if you just look at the way physics has actually evolved in the 20th century, then it's not surprising that, many of the truth that people in the history of philosophy took to be a priori don't seem to have survived. So it's not
So you support?
So I support.
Tentative conclusion.
Yes, but you were too pessimistic, I think, about it. Of course, I'm not saying anything about the methodology. Logic is. This is why I started with the first comment, because logic is something perhaps more that it would be difficult to defend, abandoning and so on, in some sense. So we have to be very careful here. But still, I think that there are. If we go into the details of these things, then yes, I think that you were too pessimistic overall. So
pessimistic about what?
About, for example, about
second philosophy?
Second philosophy, yeah.
Well, regarding the existence of different ideas or ideals of scientific reasoning, I think you're absolutely right. It's not just the Bayesian approach, but there are, alternative approaches, say that of Popper's falsificationism, or within, statistical practice, actually the most prominent, the most dominant approach is that of Fisher and Neyman and Pearson, you know, classical statistical approach. So yeah, it would be wrong to say that there is one norm of scientific reasoning concerning inductive inferences. But still so, in the empirical research that I mentioned, Kahneman and Tversky think that people should have used Bayesian updating as the norm. So one can, you know, criticize their approach on that count too. Why not pay attention to falsificationism or the idea of severe testing of hypotheses that's developed by Deborah Mayo and her colleagues, right? So there are alternatives. So you're absolutely right on that. And regarding pessimism, I'm not pessimistic. I'm just, I don't want to be too hasty about the prospects of a fully naturalized approach to normative issues. That's my position.
Thank you, please.
My impression as an outsider is that the developments that you described after Kahneman and Tversky's work should have been done by people in the discipline of cognitive science. And if they didn't do that, maybe because...
like the logicians' works must have been. Because
all the critics, you know, that you described should have been done by those people inside the discipline.
Gigerenzer and his team are psychologists mostly.
Okay. So were there philosophers in your description of, I mean, the developments, or they all were within this discipline of psychology and cognitive science?
Well, I mean, the last 2 or 3 figures I mentioned, Stenning, Van Nambelgen, and Halpern, they're logicians. Oh no, Stenning actually is a cognitive psychologist. Halpern is a logician and a computer scientist.
Yeah, but what I mean to say is that maybe because this discipline of cognitive science is young,
is what?
Young, you know, too young, so that they need help from other.
It's not that young. I mean, Kahneman and Tversky's works date back to 1970s.
No, but I mean the developments afterwards should have been, you know, within the discipline itself. So
but there are, I mean, there's
what you are saying is that
literature in the discipline itself that I couldn't mention. Huge literature.
Yeah, no, but my impression is that what you said, what you are suggesting is that the borders around the disciplines should stay.
No, I'm not suggesting that.
Like philosophers and cognitive scientists should work together, but each one should be trained differently, and they should aid each other and so on.
Yeah. But is it different from, you know, like doing laboratory research as a physicist and doing theoretical physics?
Yeah,
right?
but both are physicists. Okay, the other comment that I wanted to make was a short one. Suppose in the Kahneman and Tversky's experiment, they would have changed the probability of being engineers from 0 up to 1, you know, continuously. I believe, I mean, my prior would be that you will see changes in the endpoints or end intervals. Because 30, 70, 70, 30, you know, could be in an interval which does not make much change.
They've tried all kinds of variations on these problems. For instance, one variation is to give the profile first in the wording of the problem, and then the base rate. And it seems that that improves, or that makes people think more in accordance with Bayesian principles. Not entirely in accordance with it, but still, then people pay more attention to the last bit of information. They've tried all kinds of variations. I'm not sure of the extreme values, like 99%, 1%, but yeah, that may be a good experiment.
So thank you very much for this opening.